Linux is not really an operating system. It's a kernel, the core that manages hardware, memory, processes, and communication between software and hardware. You interact with it using a shell, the command line interface, like bash or zsh, where you type commands to control the system. That shell runs inside a terminal, a program that gives you access to type and run those commands. All files and programs live in a file system hierarchy, a tree-like structure starting from the root/directory. The most powerful account is the root user, the super user with unlimited access to the system. To keep control, Linux uses permissions, which decide who can read, write, or execute files and directories. When you run a program, Linux creates a process, each identified by a unique process ID, PID. Many of these processes are managed by an init system, like systemd, which is the first process the kernel starts and is responsible for launching services. Some of these services are daemons, background processes like sshd or cron that don't need direct user interaction. To install or update programs, Linux uses a package manager, such as apt, dnf, or pacman, which fetch software from package repositories maintained by the distribution. These programs can also depend on kernel modules, pieces of code you can load into the kernel to add features like hardware drivers. To automate tasks, you can write a shell script, a simple text file with a list of commands. Scripts and commands often rely on environment variables, like $path, which tells Linux where to look for executables. You can connect commands together with pipes, sending the output of one command as input to another. And with redirection, you can send output into files or read input from files. This works because Linux treats input and output as standard streams. stdin for input, stdout for normal output, and urits for error messages. Files themselves can be connected using symbolic links, shortcuts that point to another file or directory, or hard links, which are alternative names pointing to the same data on disk. Storage devices like USBs or partitions are added into the system by mounting them onto directories. When physical memory fills up, Linux uses swap space, an area on disk that acts as backup memory. Linux can also perform tasks on its own through cron jobs, scheduled commands that run at fixed times. The results of these jobs and many other events are saved in system logs under /var/log, which help you troubleshoot problems. Networking is another key part of Linux, handled by networking commands like ping, SSS, or IP. To connect securely to another computer,
You use SSH, which encrypts your login and commands. When you need administrative power without logging in as root, you use sudo, which lets a normal user run privileged commands. To monitor what's happening on the system, commands like top or htop show you active processes, CPU usage, and memory. Internally, processes can be controlled using signals like signal kill or signal terminate, which tell them to stop or restart. They also rely on file descriptors, which are IDs used by the system to keep track of open files and sockets. Linux can boot into different run levels, or targets, which define the system's mode, like single user, multi-user, or graphical mode.
If you want multiple terminals in one, you can use a terminal multiplexer, like tmux, which lets you split windows and keep sessions alive. For storage management, Linux provides tools like fdisk and parted to create or resize partitions, and LVM, Logical Volume Manager, for flexible disk management. File systems themselves can vary. Common types are ext4, XFS, and BTRFS, each offering different performance and features. You can check disk usage with commands like df for overall space and du for directory sizes. Security is another big part of Linux. Firewalls like IP tables or UFW control incoming and outgoing network traffic. More advanced systems use SE Linux or AppArmor, which enforce mandatory access controls for extra protection. For authentication, Linux relies on PAM, pluggable authentication modules, to manage how users log in and how credentials are checked. Linux also has a proc file system under /proc, a virtual directory that shows real-time information about processes and system hardware. Similarly, /dev holds device files, which let software interact with hardware like disks, USBs, and sound cards. Kernel and system messages are stored in the dmesg log, which is useful for debugging hardware issues. If you want to compile programs yourself, Linux provides make and GCC, tools that build software directly from source code. You can also run isolated applications using containers with tools like Docker or Podman, which package apps with their dependencies. For full machine-level separation, Linux supports virtualization through KVM and QEMU, allowing you to run entire operating systems inside Linux. Networking can go beyond SSH. Linux can share files with NFS or Samba, transfer data with SCP or RSYNC, and host services using web servers like Apache or NGINX. Monitoring networks is also possible with tools like TCPdump and Wireshark, which capture packets for analysis. Linux distributions bundle all these concepts together differently. Some focus on stability, like Debian, others on cutting-edge software, like Arch, and others on user-friendliness, like Ubuntu. Linux distributions also include a package called the kernel headers, which are needed when compiling drivers or certain software. When working with software across different environments, you can use package formats like .deb, Debian/Ubuntu, or .rpm, Fedora/Red Hat, to install programs manually. For even more flexibility, tools like Flatpak, Snap, and AppImage allow applications to run across many distributions without compatibility issues. Linux also relies heavily on systemd services, which can be started, stopped, enabled, or disabled to control background tasks. To see what's happening during startup, you can use systemd analyze
To check boot performance. If the system fails to boot properly, you can use recovery mode or a live USB to repair files and restore access. For user interaction, Linux desktops run on display servers like X11 or Wayland, which handle graphics output. Above that sits a desktop environment such as
Noom,
KDE or XFCE, which provides the graphical interface users interact with. Another key concept is shell built-ins, commands built into the shell itself, like cd or echo, which run faster than external binaries. You can also use aliases to create shortcuts for long commands, making your workflow faster. For more advanced workflows, Linux supports bash functions, allowing you to define reusable custom commands directly in your shell. Linux also treats everything as a file, including hardware, processes, and sockets, which is why directories like /sys exist to expose kernel and device information. Finally, Linux systems use init-ramfs, a small temporary root file system loaded into memory during boot, which helps the kernel load drivers before the main file system is mounted.